Hello students, welcome to EPG Pathshala. I am Vikas Singla from Punjabi University Patiala. Today we are going to talk on module time series methods of forecasting from paper operations management. This chapter would help students to understand firstly, role of variation of data in selecting a particular forecasting technique. Secondly, methods of forecasting when variation in demand is random, like simple moving average, weighted moving average, and exponential smoothing. Lastly, concept and methods of forecast accuracy, which is measured through mean absolute deviation, mean square of error, and mean absolute percentage error. Time series models of forecasting require past data to fulfill objectives of prediction. This type of data is recorded over a period of time taken at regular intervals. For example, hourly, weekly, monthly, or annually. The data collected over a selected time period can be regarding sales of a product, absenteeism rate, operating time on a machine, profits, etc. For example, sales figures collected over a period of 4 weeks can be used to predict sales of 5th week. The most important aspect to understand in the time interval for which data has to be collected. Should a particular data be collected hourly, daily, weekly, monthly, or at any other rate? Data fluctuation is directly proportional to time interval selected. It can show a trend, seasonal, cyclical, or random variation. The fluctuation behavior of data would be instrumental in deciding proper forecasting technique. Time intervals are always discussed in a relative sense. Terms such as short, medium, and long term are relative to the context in which they are used. The following table shows type of forecasting techniques, some of which would be discussed in this chapter in context of time period. Short-term period is referred as data collected over a time period of less than 3 months. Medium term is 3 months to 2 years, and long term as more than 2 years. The table indicates time period, the data pattern that varies according to the time period, and forecasting technique with respect to that time period. The first time period is short term, which is less than 3 months, and the data does not show any particular pattern or variation during this time period. The forecasting techniques that are discussed for this time period are simple moving average, weighted moving average, and exponential smoothing. The second time period is termed as medium term, which varies from 3 months to 2 years. During this time period, data either repeats periodically or move along a particular direction, that is upward or downward. The forecasting technique for this time period is seasonal and trend variation. Lastly, the third time period is long-term period, which is more than 2 years. The data during this time period shows repeated pattern but at irregular intervals with irregular intensity. The forecasting technique for this time period is cyclical method. Variation in demand. Selected time period has an influence over accuracy of prediction. If the data is collected for a very long-term period, it might provide good results. But older data may not have relevance in present scenario. Likewise, if only recent data is used, it might not be sufficient to give reliable prediction results. Thus, time period and availability of data over the time period influences accuracy of forecasting. Seasonal. Amount of traffic increases twice every day and shows similar pattern next working day. So data regarding traffic will show a repetitive cycle with equal time intervals. Cyclical. Fashion keeps on changing, with one style of clothing which had gone out of fashion would again be considered in vogue. But this happens at irregular time intervals, where it is very difficult to predict when one style will go out of fashion and when it will reappear. Lastly, the trend method. A mobile phone company might see an upward trend of sale of their smartphones over last 6 or 8 months. But with competitor launching a new variant, the company's sale might start to slow down weekly. So the sale of smartphones showed an increasing trend over monthly data, whereas decrease in sale of the same smartphones showed a decreasing trend over weekly data. Random fluctuations. Fluctuation of a share in stock market shows an irregular trend, and its fluctuation is recorded hourly or even at smaller time period. This module discusses forecasting models taking into consideration the data sets which show random variation. A data is considered to follow random variation if it is neither increasing nor decreasing over a short-term period and does not show any seasonal pattern over medium term. Following forecasting methods are discussed under this category: simple moving average, weighted moving average, and thirdly, exponential smoothing. First method that we are going to discuss is simple moving average. A data is considered to follow random fluctuations if it is neither increasing nor decreasing over a short-term period and also does not show any seasonal pattern over the medium term. The absence of pattern in this data is reflected when it is recorded with short time intervals such as hourly, daily, or weekly. The method is called as moving average because forecasted data keeps moving from one time period to another. For instance, suppose we have data for last 12 weeks and we need to forecast for 6th week by taking past data of 5 weeks. This can be done by averaging actual data of first 5 weeks and calculating its simple average. Similarly, forecast for 7th week would require data of past 5 weeks, that is from 2nd to 6th week, and in same fashion, data keeps on moving by leaving the earliest week and adding the most recent week data. In this method, following steps are used to forecast. Step 1. Select data for given time period, that is 3 weekly, 5 monthly, etc. Step 2. Add data for the selected time period. Step 3. Calculate average for that time period. The above discussed method has been illustrated by the following example. In this example, the table indicates weekly demand for 5 weeks. And we need to find out or we need to predict demand from 4th and 5th week by using past 3 weekly data. For instance, the demand given for first week is 800 units, second week 400 units, for third week 1000 units, and so on and so forth. To predict for fourth week, by taking past data, we'll calculate simple average of actual demand for week 1, 2 and 3. That is, average for fourth week would be actual demand of week 1 plus week 2 plus week 3 divided by 3. That would give us 800 plus 1400 plus 1000 divided by 3, and it would be 1067 units. For fifth week, the average would be actual demand of week 2 plus week 3 plus week 4 divided by 3, which would be 1400 plus 1000 plus 1500 divided by 3, and that would give us 1300 units. The topic is which time period to select. It will decide the concept between sensitivity and stability. Proper selection of time period is an important aspect of accurate prediction. Different time periods would smoothen the fluctuation of past data with random variations in different manner. The longer the moving average period, the more random variables are smoothed, which is desirable in most of the cases. But long time intervals face the danger of missing or ignoring variations which show a particular trend, either increasing or decreasing, occurring at smaller time intervals. Thus, long intervals would provide stable or consistent results, whereas short-term time periods would be more sensitive to abrupt or unexpected variation in the data. For example, daily data collected over a week of a stock to observe its performance may show random variation every day during that week. So, taking into consideration daily data, moving average method can be used to predict the performance for first day of next week. But if data is recorded hourly, then certain increasing or decreasing trends can be monitored which were missed in earlier data set. Thus, data collected over a short period was more sensitive to certain variations, whereas same data recorded over a longer period would be more smooth and stable.
The following table illustrates the concept of which time period to select. Whether we should select a smaller time period like 3 weekly or should we select a longer time period, that is 9 weekly. The data indicates demand or actual demand for 30 weeks. For instance, the first week demand is 800 units, for second week demand for 1400 units, and so forth. We have collected data for 30 weeks. The forecasting has been done by using simple moving average by taking two time periods. Firstly, time period of 3 week has been taken, and secondly, a time period of 9 week has been taken. By using 3 weekly simple moving average, the demand from fourth week has been calculated. The steps have been discussed in the previous slides. For instance, the demand for fourth week by using 3 weekly simple moving average comes out to be 1067 units. For fifth week, 1300 units. For sixth week, by taking the last three demands, the forecasted demand comes out to be 1333 units. Similarly, the demand for every week has been calculated till 30 weeks by using 3 weekly data. Next, the step is to calculate demand or to calculate forecasted demand by using 9 weekly data. This has been done by taking the actual demand data for first 9 weeks. This has been done by taking data for first 9 weeks and calculating its average. The average would indicate the demand or the forecasted demand for the 10th week. The 10th week demand came out to be 1367 units. The 11th week demand by using 9 weekly simple moving average came out to be 1467 units. This has been kept on repeating. The process was repeated and the demand for all the weeks by using 9 weekly past data have been calculated. For instance, in the last case, for the demand for week 30 by using 9 weekly moving average was 2378 units. Now we started off by saying that we want to understand the concept that which moving average or which time period should be used. Now this has been further illustrated by using a graphical representation for the example discussed. Shows graphically the effects of various time periods of a moving average. It can be inferred from the graph that by using 9-week period, the prediction line is much smoother and thus provides easier way of predicting next period's demand. But 3-week moving average line clearly shows that there is a sudden and sharp increase in demand after 13th week which falls suddenly after 16th week. Then there is a gradual increase in demand. Also, the line shows that growth levels off after 23rd week. Thus, 3-week moving average responds in a better manner in following this change than 9-week average. This illustration clearly demonstrates the stability effect of long term and sensitivity effect of short term. The next forecasting technique that would be discussed is called as weighted simple moving average. The main disadvantage of simple moving average is that the methods give equal weightage to each component of past data. This shortcoming is not too severe when data is collected over a short-term period. But if moving average is calculated over a long-term period, like 60-day period, then the problem of data reliability becomes more acute. The importance of data goes on decreasing with passage of time because of changing business conditions. The data which is very old may not be relevant in present scenario, so its importance is prediction should be minimal. Weighted moving average is useful in solving such discrepancy. In this method, oldest data is given least weightage and most recent data the maximum weightage or importance. The sum of weights should not be more than 1. The weighted moving average has been illustrated in the following example. The example indicates that the manager has collected sales data for last 4 weeks and would like to predict sales for next coming week by considering weightage to first week as least important and for recent week as most important. The table gives the data of 4 weeks. The week 1 the sales were 100 units, week 2 sales were 90 units, week 3 105 and week 4 sales were 95 units. The weightage in percentage has been given for each week. Week 1 weightage is 10%, week 2 weightage is 20%, for 3 and 4 it is 30% and 40% respectively. As the data indicates, the most recent week, that is week 4, has been given the most importance, that is 40%, and the oldest week, that is week 1, has been assigned the least weightage of 10%. The forecasting for 5th week is done in the following way. The weightage for each week is multiplied by the actual demand for that week and then sum is taken for all the weeks, which is 0.10 into 100 plus 0.20 into 90 plus 0.30 into 105 plus 0.40 into 95, which would give us as 97.5 units. Importantly, selection of weights is the prerogative of the manager by taking into consideration a very simple fact that most recent data is most accurate way of predicting next period and most past data is least reliable way of doing the same. The last method of forecasting technique that has been discussed in this chapter is exponential smoothing. Exponential smoothing is another method used for prediction of data which varies over a short-term period of less than 6 months and does not follow any regular pattern. In previous two methods, that is simple moving average and weighted moving average, the process of calculating averages becomes tedious if data is huge and time period selected is also large. Exponential smoothing formula, as would be discussed below, requires only immediate three data values, namely forecast and actual demand of immediate previous period and a smoothing coefficient. This method uses following formula for predicting demand. Forecast for time period t plus 1 is equal to alpha into demand for the last time period, that is t, plus 1 minus alpha multiplied by forecast for the previous time period, that is t. In the formula, ft plus 1 indicates forecast for the estimated period, that is the coming time period. dt indicates actual demand for immediate previous period. Ft indicates forecasted demand for immediate previous period and alpha is the smoothing coefficient. The value of alpha always lies between 0 and 1.
Selection of smoothing coefficient alpha. The selection of a proper smoothing coefficient value can be determined by following two methods. Firstly, an alpha value that results in least amount of forecasting error is considered to provide more accurate forecasting results. Forecast error is defined as the difference between forecasted and actual demand. Methods of calculating forecasting errors and their application in deciding proper alpha would be discussed in next module. Another way of determining a proper alpha value is its role in smoothing an irregular data. As has been discussed, this method, along with method of averages, accurate forecasting depend on how data gets smoothed by using law of averages. Such methodology is adopted because of random or unknown pattern of variation in the data. In exponential smoothing method, the random data is smoothed out by using a smoothing coefficient denoted by alpha. The value of this smoothing coefficient varies from 0 to 1. The formula as shown in equation 1 indicates multiplication of alpha with actual demand of previous period and its opposite, that is 1 minus alpha with forecasted demand of previous period. This implies that a manager would tend to use higher value of smoothing coefficient such as 0.7, 0.8, etc. if data of actual demand is considered more important than forecasted demand. In such a case, actual demand would contribute more in estimation of next period's demand. This can also be interpreted as that higher value of smoothing coefficient suggests less accurate or reliable forecast for the previous period, so a manager tends to give more importance to actual demand data. Similarly, a lower value of alpha such as 0.3, 0.4, etc. would imply more accurate forecasted data whose contribution in estimating next period's data would be more as compared to actual demand data. This has been illustrated by using following examples.
The following illustration indicates the calculation or estimation of demand by using exponential smoothing method. This illustration also indicates by taking two values of smoothing coefficient, that is alpha, that which alpha should be used by the manager in predicting demand. The example indicates the usage of smoothing coefficient alpha as 0.3 and 0.7 to forecast for the following time series data. The following table gives two things. Firstly, the time in weeks, and secondly, the actual demand for each week. For instance, 27 units was the actual demand in week 1, 30 units for week 2, and so on and so forth for 10 weeks. Exponential smoothing, as indicated in the previous slide, uses following formula, which was ft plus 1 is equal to alpha dt plus 1 minus alpha ft. By using alpha as 30% or 0.3, forecast for week 2 was calculated as f2 is equal to 0.3 into 27 plus 0.7 into 27, which gave us 27. Similarly, for F3 or the forecasted demand for week 3 was 0.3 into 30 plus 0.7 into 27, which was 27.9. Forecast for other weeks can be calculated in similar fashion, and the next slide shows final results with forecasted demand for both alpha, that is alpha is 30% and alpha is 70%. For instance, by using alpha as 30%, forecasted demand for week 2 was 27 units and for week 3 it was 27.9 units. Similarly, for last week, that is for week 10, by using alpha as 30%, the forecasted demand was 30.42. The last column in the table indicates the forecasted demand by taking alpha as 70%. For week 10, by taking alpha as 70%, the forecasted demand was 31.26 units. By using this illustration, we wanted to illustrate, or we wanted to understand the concept of which alpha to be taken. Should we take alpha as a low value of 30% or alpha of high value of 70%? This was illustrated pictorially by using a graphical representation. Slide clearly shows that with alpha zero point 0.3, more smoothing effect is provided to the random data than with alpha as 70%. The line with alpha as zero point 0.3 is much smoother as compared to line with alpha as zero point 0.7. From this, it can be inferred that forecasted done for week 11 would be more accurate by using alpha as 30%, which has been calculated as forecast for week 11 would be 0.3 into 31 plus 0.7 into 30.42, and our answer would be 30.59.
To conclude, this chapter discusses methods of forecasting when demand or any other data varies over a short-term period. It has been emphasized that during such short-term period, it is difficult to assign a pattern to demand fluctuation. Thus, methods as simple moving average, weighted moving average, and exponential smoothing, which have been discussed with illustrations, are applied when fluctuation in data is random and unknown. Simple moving average gives equal importance to every data value. But with passage of time, old data has less relevance to present conditions. Thus, its importance decreases. So, weighted moving average was devised to give different weights to different data values depending on their occurrence in time series. Oldest data was given least importance and recent data the maximum. These two methods faced with another problem. In both the methods, a manager has to carry all of data to predict for future time periods. In big data sets, this becomes quite a tedious task. Exponential smoothing method helps to resolve this problem to a great extent. Thank you.